Hello everyone, I'm Redeline Yumul, a senior high school mathematics teacher. For this video, given a rational function, we will specifically determine its domain, intercepts, and vertical asymptotes using CASIO class V's. We will also represent a rational function through its table of values and graph. And finally, we will try to solve a rational equation with the use of CASIO class V's. The examples and steps to be discussed in this presentation are also indicated in the CASIO book about rational function. As defined, a rational function is a function showing the quotient of two polynomials, p and q, written in the form p of x equals p of x over q of x, where q of x is not equal to 0. Now, its domain is a set of real numbers except for the values that will make the denominator equal to 0. Let's have an example in identifying the domain of a rational function. In this rational function, we will compute the zeros of the denominator to identify the domain of this given function. The basic buttons to be used in identifying the domain of a rational function are Shift, Alpha, X, and Calculate buttons. We will use the Calculate menu of the CASIO class V's, and to proceed, we'll press Menu and then 1. Then we input 2x plus 6. Then we press Alpha and Calc to place an equal symbol on the screen and then press 0. To automatically compute for x of this equation, press Shift, Calc, and Equal buttons. So the domain of f is the set of real numbers except -3. Another example, observe that the denominator of this given rational function is a quadratic expression. To solve for its zeros, we will use the equation menu of the CASIO class V's. To proceed to the equation menu, press Menu, Alpha, and negative symbol buttons. Choose polynomial by pressing 2 and then input another 2 for the degree of the polynomial. Input each coefficient of the quadratic expression and press Equal button to enter each value. That is, input 2 equal, that is, input 2 for A, 5 for B, and 2 for C. After which, just press the Equal button to determine the zeros. So the domain of G is the set of real numbers except -1/2 and -2. For the third example, we will determine the intercepts of this given rational function. Recall that the x-intercept of the graph of a function is the abscissa of the point where the graph intersects the x-axis, and y-intercept is the ordinate of the point where the graph intersects the y-axis. So to identify the x-intercept without graphing the rational function, we will identify the zeros of the numerator. Using the Calculate menu, that is menu 1, input x plus 5. Then press Alpha, Calc, and 0. To automatically compute for x of this equation, press Shift, Calc, and Equal buttons. Therefore, the x-intercept is -5, or the graph of this rational function will pass through the x-axis at point -5, 0. Next, to identify the y-intercept, substitute 0 to x of this given rational function. Using CASIO class-ways, the calculate menu is needed. Input the rational expression. We press fraction key, x plus 5, right arrow key, 2x squared minus 3x minus 2. Then, press calc and input 0 for the value of x. Then we press the equal sign twice. Therefore, the y-intercept is negative 5/2, or the graph of this rational function will pass through the y-axis at point 0, negative 5/2. Let's try another example. This time, let's identify the domain and intercepts of this given rational function. So to identify the domain of this rational function, again, we will identify the zeros of the denominator, and since the denominator is a polynomial expression of degree 2, we will use the equation menu of the CASIO class-ways. To change into equation menu, press Menu, Alpha, and negative sign button. Then we choose polynomial by pressing 2, and then input 2 for the degree of the polynomial. Input each coefficient of the quadratic expression x squared minus 7x plus 10 and press equal button to enter each value. So we have 1 for A, negative 7 for B, and positive 10 for C. After which, just press the equal button twice. As indicated, the domain of this rational function is the set of real numbers except 2 and positive 5. For x-intercept, we will identify the zeros of the numerator, and since the numerator is a polynomial expression of degree 3, again, we will use the equation menu of CASIO class-ways. Again, press Menu, Alpha, and negative sign button. Choose polynomial by pressing 2, and then input 3 for the degree of the polynomial. Then we input each coefficient of the cubic expression and press equal to enter each value. That is, input 1 for A, negative 2 for B, negative 1 for C, and 2 for D. Then we press the equal button twice. After which, just press the equal button to determine the zeros. As indicated, the values are negative 1, 1, and 2. However, 2 is not part of the domain of this rational function. Thus, the x-intercepts are only negative 1 and 1, or this rational function passes through the x-axis at points negative 1, 0, and 1, 0. Lastly, to identify the y-intercept, substitute 0 to x of this given rational function by using the calculate menu of CASIO class-ways. So press Menu, 1. Input the rational expression. Press fraction key, then input x cubed, right arrow key, minus 2x squared minus x plus 2, right arrow key, then we input x squared minus 7x plus 10. Then press calc and input 0 for the value of x. Then press the equal sign twice. Therefore, the y-intercept is 1/5, or the graph of this rational function will pass through the y-axis at point 0, 1/5. For example 5, we will identify the vertical asymptote of this rational function. The vertical asymptote of a rational function is the line x equals a, where a is any real number such that as x approaches a, either f of x approaches positive infinity or negative infinity. To identify the equation of the vertical asymptote of a rational function, we need to compute for the zeros of its denominator. So the process is the same as identifying its domain. To solve, using Calculate menu, we input 4x minus 8. Then we press Alpha, Calc, and 0. To automatically compute 4x of this equation, we press Shift, Calc, and Equal buttons. So the computed value is 2. Thus, the vertical asymptote is at x equals 2. Let's try another example in identifying the vertical asymptote. Again, the process is the same as identifying the domain of the rational function, and since the denominator of this rational function is a quadratic expression, we will use the equation menu. So we press Menu, Alpha, and negative sign button. Then we choose Polynomial by pressing 2, and then input 2 for the degree of the polynomial. Input each coefficient of the quadratic expression and press Equal to enter each value. So we have 2 for A, negative 3 for B, and negative 2 for C. After which, just press the equal button to determine the zeros. With this, the vertical asymptotes are x equals negative 1/2 and x equals 2. For example 7, we will construct a table of values of this rational function presented in example 5. Using the table menu, press Menu and 9. Input the function by pressing fraction, x, right arrow key for x minus 8. Since we will only construct a table of values for one function, press Equal button again. Assign values for x by completing the table range. Let's say from negative 5 to positive 5. Then we press the Equal button to input each value. That is negative 5 equals 5 equals, and then for the interval of values, let's leave this as 1 unit. Then press again the Equal button to reveal the table. Observe that when x is 2, f of x is error. This confirms that the domain is the set of all real numbers except 2. To graph this rational function from the table of values presented on the calculator screen, press Shift and Option. A QR code will be flashed on the calculator screen. Now scan it using QR code scanner or using CASIO Edu Plus app. Then, open the link once the QR code is scanned. You will be directed to Worldwide Education Service of CASIO that presents the graph of the given function. With this graph, it is obvious that the domain is the set of real numbers except 2 and that the vertical asymptote is x equals 2. Also, the graph of f of x equals x over 4x minus 8 passes the x and y axis at point 0, 0. Let's try another example. Press AC twice to delete the previous function. Then we input the rational expression and press the Equal button. So press fraction key, input x plus 5, right arrow key, input 2x squared minus 3x minus 2. Again, we press the Equal button twice. For the table range, this time let us use negative 3 to 3. And for the interval, let's use 0.5. So we input negative 3, equal sign, 3, and 0.5. Then we press again the equal button twice. The table of values verifies that the domain of this function does not include -1/2 and +2. And for the graph, press Shift and Option. Then, scan the QR code flashed on the screen. Again, you will be directed to Worldwide Education Service of CASIO that presents the graph of the given function. With this graph, it verifies that the domain is the set of all real numbers except -1/2 and 2, and so the vertical asymptotes are x equals -1/2 and x equals 2. This time around, let us solve this rational equation. Recall that a rational equation is an equation that has at least a term which is a rational expression. To solve this given rational equation, Calculate menu can be used to easily compute for the value. So press Menu and 1. Then we input fraction 2x plus 1, right arrow key, input 3x, right arrow key, then we input an equal sign by pressing alpha calc, fraction button again, input 2, right arrow key, and then x. After which, we press shift, calc, and equal sign. So the value of x that satisfies this rational equation is 5/2 or 2.5. Now, let us apply this method in solving word problem involving rational equation. To construct an equation for this problem, add the portion or part of the house that can be done by each person alone in 1 hour. Then, we equate to the portion or part of the house that can be done if the three of them will work together. Since Rakhmel can paint the house alone in 4 hours, then, estimately, Rakhmel can finish 1/4 of the job in 1 hour. Rain can paint the house alone in 6 hours, so 1/6 of the job can be done in 1 hour. For Raphael, since the number of hours to finish the job is unknown, then we represent that by x. So the portion or part of the job that can be finished in 1 hour is 1/x. Lastly, if all of them will agree to work together, they can finish the job in 2 hours, so 1/2 part of the job can be finished in 1 hour. So the rational equation is 1/4 plus 1/6 plus 1/x equals 1/2. Now let us solve this rational equation using CASIO class Swiss. So we press fraction button and input 1/4 plus 1/6 plus 1/x, and then for the equal symbol, press alpha calc, and then we input 1/2. Lastly, we press shift, calc, and equal buttons. Since x is 12, it means that Raphael can paint the house alone in 12 hours. So that's it for this video. Thank you and have a good day.